A point reflection moves each point straight through a chosen center so that the center becomes the exact midpoint between the original point and its image. We will first describe the movement geometrically, then turn that movement into coordinate rules, connect it to a 180-degree rotation, and finally use its properties to recognize symmetry. The key starting idea is the midpoint relationship between a point, its reflected image, and the center. Starting from the midpoint idea, a point and its image must lie on one straight line with the center between them. The reflected point lands the same distance past the center, so the center is exactly halfway between the 2 points. With the center fixed as the halfway mark, the movement from the original point to the center is repeated in the same straight direction beyond the center. That makes every point slide through the center and stop at a matching distance on the other side. Because the center is the midpoint, each coordinate of the center is the average of the original coordinate and the image coordinate. If the center is a comma b and the original point is x comma y, solving the midpoint relationship gives the image point to a minus x comma 2b minus y. When the center is the origin, both center coordinates are 0, so the general rule becomes much simpler. The point x comma y maps to negative x comma negative y. Since every point travels through the center and comes out the same distance away, the effect matches a turn halfway around the center. A point reflection is the same transformation as a 180-degree rotation about the center. With the transformation understood as a half turn, the shape is not reversed the way it would be in a mirror reflection. The image is turned upside down around the center, but its front-to-back order is not flipped. Because a half-turn moves all points by the same kind of rigid motion, distances between points and angle measures do not change. The reflected shape is congruent to the original shape. Since the center is already the midpoint of itself, the center does not move under a point reflection. Every other point moves to a partner point, and reflecting a second time sends each partner back to the original position. With the coordinate rule and half-turn meaning in place, a shape has point symmetry when the point reflection sends the whole shape onto itself. Shapes such as a parallelogram or a regular hexagon can match themselves after this 180-degree turn, so they have point symmetry.